Hi, so this is Chapter 8, Dynamic Addressing. And I'm going to do a series of videos, probably 6, maybe a little more, because I want to keep them short. But here's the thing that I want you to get with dynamic addressing, is I thought about how to talk to you about this. We're so familiar with static addressing, and we're so familiar with command line interface, writing commands, configuring the device, the host, the router, the ports, all of this. And we've talked about moving from IP address v4 to v6 because we needed more addresses and more address space. And we said, well, hey, dynamic addressing will help later with that. We're also going to see where network address translation helps with that. But dynamic addressing is not about extending the address space. Don't even think that. Dynamic addressing is about managing a box of addresses. It's the same thing as a landlord owns a hotel, or better yet, the landlord owns a building that contains a lot of apartments, and he's got to keep those things leased and filled. That's his object as a business person. Got to have those things filled. Well, dynamic addressing, you don't got to have them filled. You've been assigned a block of addresses, okay? You're not going to be held responsible that they're all filled or not filled. What you are going to be held responsible for is managing who's in those addresses and what they get used for, and how long they get used, and who else needs them, and so forth. Exactly the situation that goes on in the DKI building. We've got one manager. It's the router in the back behind the electronics lab. But we've got a variety of users coming and going all day, all week in the 2 classrooms and then in some of the labs. Okay? So, but then we've got a number of fixed addresses that go there that do remain static. All the printers, any cameras, our 3 racks in the back of the Cisco room. Those are fixed addresses. Okay, so they don't need management. They're assigned. You give them, they're there. But there's a block of addresses that the use of the terminals is quite varied. And so the way a manager manages a building, or a hotel manages all of its rooms, you make a reservation, the hotel has it for short-term stays. But the process is still the same. You need a lease, and we're going to use that term lease. And it contains conditions for ownership of the room. The number of days, the number of months, years, whatever it is. You negotiate that lease. And when the lease is up, the address expires and you lose it. Okay? So there's obviously conditions in a network for reestablishing the lease. That sort of stuff is all there. But it's basically a leasing process for the purpose of managing addresses. Now I'm going to bring up the slides and we'll head from there. Okay, so here we are with our usual slides. We're going to be doing version 4 and version 6. But once you learn one, the other is going to be very, very similar. So we're doing version 4 first. We'll spend a little bit of our time with that. And here we go. So as an intro, here's the terms. The landlord is the server, right? The customer, the renter, is the client. And so notice how this whole process starts here. It starts over here. Number 1, I'm the client. I come to the landlord, I say, I want to rent something. I need the services of DHCP for IP addressing and other information. And the landlord decides, oh, I can provide you an IP address and other information. This is the start of a negotiation process. Okay? So be clear about that. This is the start of that process. So it's going to assign IP addresses. It's going to have a pool of addresses that it works from to do that. Cisco routers, they can be configured for this. Actually, Juniper's routers, anybody's routers can be. Netgear's routers. I have this at home, and I've got a whole bunch of different computers and some printers and stuff. And I've noticed those addresses are not static. No, they change all the time. So my router, without my telling it, because it's a consumer job, is basically using this process, assigning DHCP4, v4 addresses. Okay, so they're going to be done as leases, and they're going to be configured to expire, just like it says here. And then the client's got to ask for renewal. That's why I'm saying don't lose this. Don't lose that this process is going on. Okay, so what's next? So you have these pictures, and I'm gonna annotate them as needed. But if you keep in mind the landlord-tenant idea that I put in your head, stay with that. So how does it go? Something called a DHCP discover is sent out by the client, right? That's this thing right here. Whoops, I got an eraser on the pen. The DHCP client is right here. Okay, and all you need to know is that term, the DHCP discover, is going on, and it's a broadcast. That's the key thing. The landlord responds with an offer. He says, here's an address I can offer. Now notice this is just an offer. It's a request and an offer. I knock on the landlord's door. I want to rent an apartment. Well, let me show it to you. Let me see what we got. Here's the offer, right? Then the client comes back and says, I accept that address. And now notice here, each of these things, if I can get it, each of these has a different name type. There's the request, the discover, the offer, and then the request. Now it's an odd name to call that a request, but it's really an acceptance. And then the final is the landlord has to close the deal with an acknowledgement, right? That's this guy right here. Now notice something else. The landlord is always using unicast. The client is always using broadcast, right? The client he doesn't know this landlord. All he does is knock on the door. Somebody answered, and that's the server. And those roles remain the same. Broadcast, unicast, because the landlord, the server, is talking to one person, one client, okay? So the client is always broadcast, and the server is always unicast, right? Now, lease renewal, without it being specified, it's half the time of the lease, right? So I can keep renewing. Now they're both in unicast mode because they know each other. They've got a contract. So now the client has moved to unicast because this is one-to-one. This is you and me, unicast. I'd like to renew it. Okay, I acknowledge it. I renew it. Now, one of the things that I wondered when I was preparing for this was, why would the client ever not accept the lease? You know, I wondered. Over here, the server offers the lease. The client says, oh, okay, I accept that. And then the server says, well, I accept you. Now, why would they not accept the lease? Well, there are strange cases sometimes. There seems to be only two reasons. One is that the address is duplicated someplace. And that would be a fairly sophisticated, unexpected problem. But the client might know it. And the other is something called scope. And maybe the address that got offered doesn't have The address that got offered doesn't have enough capability. You know, the offer, the terms of the offer didn't include enough scope that the client was going to be able to do its job successfully. Okay? So here's the message format for this. And I just want to get this on the table. So this one may run a little longer than the 10 minutes here. But first there's this opcode, and there's basically in this server client thing, this is going to be the Universal Datagram Protocol, the UDP protocol. So it's very simple. You might want to go back and review some of that. We had the choice of UDP and TCP, Transmission Control Protocol. One is very protected and more secure. That's TCP. UDP is just sort of a streaming thing. And if somebody misses it, it's lost. So, but once you get in the message format, because I mean, you can banter, you know, to set up the lease, they can banter back and forth a lot, obviously. So the opcode says, am I either a request or a reply? So it's the same format on either side of the transaction. Then there's something about the hardware type. Is this an Ethernet? Is it gigabit Ethernet, fast Ethernet? Is it a serial port? What have we got here? So you get a chance to specify that. Now the numbers up at top, 8, 16, 24, and 32, those are just, you know, the number of bits up to that point. Each of those are a byte long. There's a hardware address length that's given, right? And then also the number of hops can be set. The client sets this to 0 at the start. All right. Now, inside the transaction identifier, there's some number of seconds that have elapsed. And there's some flags that can be set. It turns out there's not much in the way of flags in this proposition. And then there's a series of things that are the client IP address. This is the one that can be offered. Your address. We'll learn more about these in greater detail. Down here are the MAC addresses. The MAC address is being included. So there's a lot of detail here. If the server has a name, you'll be doing some packet tracers where it's named or it's not named. And then something about the boot file. And then there's options. These can be variable and they can be changed. So you can see there's a lot of stuff here that could be negotiated outside of the address itself. Okay? So, I want to show you something quickly here. This is another picture of that same arrangement. And you'll notice up here, it says that it's UDP. And there's a source port 67 coming from the client. That's the client because it's going right to left. And here's the destination port. This would be the server, right? And this would be the client. Now it turns out, now when the offer comes back, notice those have switched. The source port is now 68, which is the client. These ports, by the way, you can look up. They're part of the UDP protocol. And it's along with the tons of other ports available, including private ones that could be had. Now it says the destination is 67. Okay, and so the client is 67, whether it's a source or a destination. And in a minute, I'm going to get to the one that's in your text, and it's a little confusing. So notice here, the client retains being 67, and the source retains being 68. So those flop back and forth depending upon which way the session is going. But some other unusual things are true about this. What's true is this gets one label, and the server over here gets one label. But the protocol that this all grew from, called the boot protocol, these numbers were actually assigned the other way. So if you go prowling around on the network and so forth, you may sometimes find in a protocol called boot P, you can find all this on Wikipedia, where it lists all of the ports. The port address 67 is actually assigned over here. Whoops, if I didn't go too far. The server is actually assigned 67, and the client is assigned 68. And I haven't resolved that yet, except to try it online with hardware, which I haven't got a chance to do right now. Okay, so that's something. So here's a UDP datagram, right, over here. We've got source ports, destination ports, a length, and a quick checksum, and that checksum only checks for errors during transmission. Okay, the data is this piece that I just had up. This piece plugs in down here as data. Okay? Now, here's a couple of screenshots from your text, and you see here, now we've got the client on the left, sending to the right, a little confusing. This is the server's address, 192.168.124, okay? And this is the client's address. So when you do the discover, the client does the discover, he doesn't have an IP, right? It's question mark, doesn't have an IP. But he does know his own MAC address, he's got that, and he's going to do a broadcast. So that's what's happening here with the all Fs, right? I'm doing basically a layer 2 broadcast, and that's consistent with this, my source address. I don't know anything, but this is a source broadcast, and there's nothing in here, okay? And none of these other fields are filled in because he doesn't know them. All he knows is this is me, and I'm broadcasting it out there, and I'm going to go for this is a discover message, okay? So now here comes the offer back. Now the server knows more about this situation because he knows who he is. Okay, so here's the media access control. I'm going back to you, right? So I got you, and here's my media access control. And more than that, this is me coming back. Okay, and my UDP port is 68. This is the port in question that I told you in the previous slide. The boot P protocol says it's 67, but regardless, it stays the same. That's the server port. Okay, these are just, for your convenience, declarations of what those abbreviations mean. But here's what's happening. I'm offering you this address. That's the offer. Okay, and here's the mask, the rest of the address. I haven't given you a gateway address yet, but it's going back to you. Right now, the gateway that goes along with this is all zeros. Okay, so that's the offer going back, and that's the one that the client is going to have to respond to with the simple request and acknowledge. So I'm going to quit this for the day. This is like our startup with this. And we'll get on more with it in the next one. Sorry that this one runs a little long, but it got us off the ground. Keep in mind, we're leasing things, and the lease has a term limit to it. And it's just like renting an apartment or renting a room.